Okay, so we're going to review ratios and proportional relationships. Let's try to find which of these represents a proportional relationship. If we look at these, we need to find a constant ratio. So we're going to take our y and divide it by our x. Remember, it's always this one divided by that one. Your independent variable is always on the bottom. So 3 over 1 is equal to 6 over 2, which is equal to 9 over 3, which is equal to 12 over 4. That's a true statement. They all equal 3 over 1. So the rate of change is 3 over 1. So this one is a proportional relationship. This one, however, is not a proportional relationship because if we look at these, even the first two don't work. 4 over 1 does not equal 5 over 2, which does not equal 6 over 3, because when we simplify these, they don't all have the same ratio. Okay, so if we look at these and we all make them a unit rate of 1, they all have different numerators. That one is not a proportional relationship. Another indicator is that it has to go through 0, 0. Okay, so if we look at this one and we go back 3, back 3, back 3, and then here we go back 3, we're at 0. If we go back 1, back 1, back 1, if we go back 1 more, we're at 0. So this one passes through at 0, 0. If we look at this one, we're going back 1 every time to 0. Here we're going back 1 every time, and this one would pass through at 0, 3. So again, we know it's not a proportional relationship. We know this one is because it's got that constant rate of change times your x. It looks like all of the equations that we've written, where we have y equals k times x, or I've also told you it's y equals mx. This one, however, has this added 8 on. It's a negative 8. If we didn't have it there, it would look like it's a constant ratio. But because it's there, this one is not a proportional relationship. E works because it passes through at the origin, and it increases every single time, 3 going up and going to the right 2. And it's doing that every time between each and every dot. So the constant rate of change is 3 over 2. If we look at this one, it does not have a constant rate of change. At this point, it kind of turns. And instead of continuing on as a linear straight through, it stops here and then it changes slope. This is not a proportion. So now they want us to pick a table from above and write the equation that can be used. This one is the only one that we can use because it's the only one that's a proportional relationship. So again, the rate of change was 3 over 1 because every time this changes by 3, this one changes by 1. Okay, and both are positive, so it's 3 over 1 or just 3. So my equation is y equals 3 times x. If we look at E, this one is the only one that works for our graph. It's going up 3 and over 2, so our equation is y equals 2/3 times x. Okay, in this problem, Payne is driving to a friend's house. The number of miles Payne drives is proportional to the amount of time he drives. He's going to drive 45 miles in 60 minutes. Don't forget the stop sign and the street signs. If we see 60 on this, it's miles per hour. Okay, so we are looking at miles per minute in this case. So it's 45 over 60. That can be simplified. What number goes into both 45 and 60 evenly? 15 goes into 45 3 times, and it goes into 60 4 times. So the only one that works is B. Remember, though, in class, I told you can check your work. So if you wanted to plug in 45 for your miles and keep the 3/4 and plug in 60 for your time, if you take and you multiply 3/4 times 60, you get 45. And if they are equal, that means that you did something right. So if you forget and you think, oh, it's 4 over 3, you'll know you're wrong when you multiply the 60 times the 4/3. If you look at number 5, John made a graph that represents the distance traveled while flying his plane. Your y is going to be the amount of time that passes. okay, or excuse me, is the distance. So the y is your distance. So this 300 equals your distance. Your x is the amount of time that passes. So your x equals time. So we always do the independent variable on the bottom and the dependent variable on top. So it's 300 over 1. It's always this y over this x. So you're going 300 miles per hour. We don't say I'm going 1 hour per 300 miles. We say 300 miles per hour. So we know that at 300 miles an hour, this is going to be my slope or my rate of change, which means in our equation, it's the y equals the mx. And remember, this m is like a mountain. Remember, it's like your slope. These are like your mountain hills, okay, that you're going to go up and down the ski slope. This is your slope, so we plug that into this equation. But it's got to be simplified. So what's 300 divided by 1? Just 300, and that gets multiplied by your x. All right, so they give us some statements about this. We know that my slope was 300 over 1, which was my miles per hour. Which of these statements down here explains this slope? A does. He's traveling 300 miles per hour. So we know A works. We also know that this is the slope, 300 over 1, because in my equation, that would be what it looks like. The y-intercept is not 300. Remember, that's where it passes through at 0. So it's passing through 300 at 1, and it's passing through at 0, 0. So that y-intercept is not true. And he's not traveling 1 mile in 300 hours. That doesn't even sound like a plane ride. Okay, so make sure you check that as you go. Okay, so now we're going to look at the number of hours and the number of pages read in a book. Okay, the hours is independent because time is going to go by whether or not you're reading the book. The amount of pages you read in the book depends on the number of hours. So we always take and we divide our dependent variable by our independent variable. And when I do so, each one of these is going to give me a different amount. For example, if I divide 37 by 1, I get 37. If I divide 73 by 2, I get 36.5. If I divide 109 by 3, I get 36 and 3/10 repeating. If I divide 145 by 4, I get 36 and 25 hundredths. So these are not proportional. Okay, so it also does not pass through 0, 0. So there's two things. It does not have constant ratios, and it doesn't pass through the origin. Okay, what about number 7? This one, we divide this by 1, this by 2, this by 3, this by 4, and all of them equal 275. So in this case, it does have constant ratios. And if we went back $2.75, we would be at 0, 0, so it passes through the origin. On 8 and 9, they want us to find the constant rate of change. So each and every one of these is increasing by 100, while the number of trees is increasing by 5. That means that there are 100 apples on every 5 trees. So how many is that for one tree? If we look at that, it would be 20 over 1. Okay, so 20 apples on one tree. So this is our constant rate of change, or our croc, as I like to call it. Over here, this constant rate of change is rising 10 and running 1, or here it's rising 20 and running 2. Over here, 30 over 3 and 40 over 4. So it is constant at 10. If we simplify 10 over 1, you get 10. Okay, this is the last one I have for you. Let's look at the votive candles and their cost. If I buy this amount of candles, it costs me $4. And it's directly in between 0 and 4, which is $2 $4 for 2 candles. So if we divide, we get $2 per candle. So 1 candle costs $2. If we look at this one, it's $8 for 4. So again, that's $2 per candle. So the equation is y equals 2 times x, and it's $2 per candle. That's all I've got for you, so I'll see you next time.